Ayan. Pasensya na kayo class, ay ako'y na late kasi nga naman na nagkaroon pa ng meeting kasama ang school president. Kaya na late ako. Para hindi na tayo kumbaga mag-remedial kasi sabi kasi nila mag-remedial na lang daw. Kaya available naman ata kayo class ngayong araw, wala naman kayong klase. Kaya para din na tayo mag-remedial sa ibang araw. Kaso nga lang yung kainta ang problema ko dahil hindi nakaka-join. Wala kasi akong gist sa kanila. Hindi naman sila nag-message sa FB. Kaya dito na tayo. Actually, ang lesson man natin ngayong class, madali lang naman. Ano lang siya, parang simple lang. Hindi naman siya totally kahirapan. So, dito na tayo. Ayan. So, wag na tayo class magdasal, dahil masyado na tayong banal. Pero sige, magdasal na muna tayo para ito paano lang yun. May guidance tayo ni Lord. So, let us pray na muna.
Good morning, Lord. Thank you for a new day. Thank you that your compassion is renewed every morning. Great is your faithfulness and your steadfast love, O Lord. I don't know what all is going to happen today and how much I'll get done, but you do. So I give this day to you. Fill me with your Holy Spirit, Father. Energize me for your work, because you know how tired these bones are. Awaken me to the wonder of your salvation and quicken my spirit to the reality of your work in my life. Lord, my mind is filled with creative ideas, but they're all jumbled. Holy Spirit, come and hover over my mind like you hovered over the waters at creation, and speak order out of the chaos. Help me to cease striving and to trust that you will give me all I need today to do the work you've given me to do. You will be faithful to complete the good work you've started. And as I step out into my day, I declare your sovereignty over every area of my life. I entrust myself to you and ask that you use me however you see fit. This day is yours. My body is yours. My mind is yours. Everything I am is yours. May you be pleased with me today. Amen.
Ayan. So once again, class, good afternoon. Good afternoon. Sa binangonan ba kayo? Tignan ko sa kayo ay taytay pala. Taytay at saka kainta. Pasensya na kayo kasi nga naman ay nagkaroon kami ng meeting kanina with the college president. Hindi naman ako pwedeng umansin. Baka mapagalitan naman ang inyong abang lingkod. Medyo mahigpit kasi yung si Ma'am Bibigyan. Alam niyo naman ako. So dito na tayo. And I think nasabihan naman kayo class ng ating mga alam mo to, mga features na nasa GC nyo na wala tayo pasok kanina kasi ayun, may meeting. Mag-attendance na kayo class sa ating chat box. So ayan yung meeting namin kanina. Ito yung college president, kasi ito naman ako kanina. Hindi ako makapasok kanina kasi kami yung meeting. So dito na tayo. Teka lang, saglit lang. So ayan. So here are class the different objectives of our lesson for this afternoon. Number 1, define Boyle's law and Charles' law. Illustrate class the relationship between pressure, volume, and temperature. Apply Boyle's law and Charles' law formula. So these are the objectives. Now we have here now class about a short video about what is Boyle's law all about. So let us watch this one.
Good day, learners. This is engineering. This time, we're going to talk about Boyle's law. In a gas, its physical behavior is described by these 4 variables, namely pressure, volume, temperature, and amount, or mole. In this video, we will have Boyle's law, which is concerned in the relationship of pressure and volume. Boyle's law was formulated by the famous scientist Robert Boyle in 1662. This law relates the expansion and compression of the gas at constant temperature. In his experiment, he has a J-shaped tube with the shorter end closed and the long end open. He put mercury in the tube and determined the volume of trapped gas. When he poured some more mercury, he found out that the volume of trapped gas decreases, while the change in height of the mercury increases, which indicates the pressure also increasing. Having all the data, we then find out that volume and pressure follows this graph as shown. When we write it in mathematical terms, we have volume is inversely proportional to pressure. This relation can be also expressed as the product of pressure and volume is equal to some constant. If we have a gas under 2 different conditions, we can write the formula as P1 equals P2 V2. In the formula, we can see that under a certain condition of the gas, increasing the pressure would result to decreasing the volume, or increasing the volume would result to decreasing the pressure. For example, the initial volume is 5 liters at pressure 1 atm. What is the volume if we increase the pressure to 2 atm? We first identify the given. So we have, now we're going to find the final volume. We substitute the known values in the formula. Now solving for the final volume, we have, therefore the final volume is 2.5 liters. We noticed here that the final pressure is doubled, so we expect for our volume to be half. That's it. That is all for now. I hope you learned something today. Once again, this is Easy Engineering.
Okay. So that is class na what we call the relationship between pressure and volume when it comes to Boyle's law. Teka lang, may nagpapasip pa. Okay. So this is class how Robert Boyle looks like. He is considered class as the father of modern chemistry. He was an Anglo-Irish scientist. He was born in Ireland, you know. He was the first to perform experiments under controlled conditions and publish his researches with elaborate details of procedure and apparatus and observations. Si Robert Boyle class ay kilalang-kilala din class sa chemistry dahil nga naman sa ginawa niyang law na tinatawag natin class na Boyle's law. Okay? Sabi natin dito, in every gas flow class, we are about to pertain the different variables. Ano ba yung mga variables natin class sa chemistry? Meron tayong pressure. Meron tayong volume. Meron tayong temperature. And meron tayong class na tawag na amount. At ang ginagamit natin class na unit for class. Sa pressure naman class is either millimeter of mercury, either atmosphere, pwedeng class kilopascal, pwedeng pascal, or pwedeng torr. Yung class mga ginagamit natin class na unit sa pascal, sa pressure. Sa volume naman class, more often class, gumagamit tayo class ng unit na liter. Sa temperature naman class, wala tayong ibang ginagamit na unit kung hindi Kelvin. Kaya kapag naka-degree Celsius yan, i-convert mo siya class into Kelvin. And for the mole naman class, ginagamit natin class na unit for mole ay lowercase.
Kape lang naman. Ano ba?
Teka lang, may maingay sa biglang. Okay, so those are the what we call four variables class in gases. Now we have mentioned class the word Boyle's law, or this particular law, Boyle's law, pertaining class the relationship between pressure and volume. No, as what we have watched class in our video, it states that the volume class, or should I say the pressure and volume class, is what? Directly proportional. Ibig sabihin yan, inversely proportional pala, sorry. Inversely proportional. Ibig sabihin yan, class, when the pressure class increases, the volume decreases. But when the pressure class decreases, the volume class increases. So para siyang seesaw. So that is class the relationship between pressure and volume. Or sabi natin dito, if you are going class to get the product between pressure and volume, you are about class to arrive class at what we call constant. And the constant here class is the temperature. Okay? So teka lang, may didilitin lang ako. Merong hindi na-delete. Ayan. Balik tayo sa ating pinag-uusapan. Ayan. So dito na tayo. So let us now have class an example about Boyle's law. Saan ka na ba ito? Suppose class you were given an initial volume of 2.5 liter, and your final volume class is equal to 1.6 liter, and your initial pressure class is equal to 4.6 atmosphere. Yan, 4.6 atmosphere. Ngayon, kapag halimbawa class ay nag-face-to-face na tayo, dahil next time, mag-face-to-face na tayo sa ating mga laboratory, i-apply natin class yung GRESA method or approach. Naalala niyo pa ba ito? Naalala niyo pa ba ito? Yung given, required, equation, solution, and answer. I-apply na natin ito class kapag nag-face-to-face na tayo. Ngayon, you were asked class to find the final pressure. If you are going class to analyze the relationship class of initial and final volume, we can say that the volume of this solution, it decreases. It decreases. So from 2.5, it became 1.6. So therefore, class, since the volume class decreases, so somehow we can expect that the final pressure class, sabi natin dito, should also should increase. Kasi sabi natin dito, mayroong pagbaba ng volume from 2.5 naging 1.6. Eh, di ba inversely proportional class ang volume at saka pressure? Eh, kaya ibumaba ang ating volume. So therefore, class, tumataas ang ating pressure. So we can expect class a higher value for final pressure from 4.6. So let's see what will happen. And then let us now use class the formula for Boyle's law. We have initial pressure times initial volume is equal to final pressure, final volume. And then you substitute. Ang ating initial pressure class ay 4.6 atmosphere. Ang ating initial volume naman class ay 2.5 liter. And the final pressure class is the unknown times the final volume class, the 1.6 liter. Okay? And then divide both side class by 1.6 liter. This will become cancelled. And the same unit will be cancelled. So therefore, class, our final pressure class will be, use your calculator. So 4.6 times 2.5 equals, divided by 1.6 equals, so magkakaroon tayo class ng final pressure class na 7.19 atmosphere. So sabi natin dito, ang ating final pressure class should increase. So tignan natin from 4.6 to 7.9. So we are correct. It increases class, from 4.6 to 7.19. So you have also class to consider, the relationship class of pressure and volume in finding class or arriving your final answer. Kasi baka mamaya, mali yung sagot mo, o kahit pa paano malalaman mo. Kasi sabi natin dito, hindi pwede class na yung final pressure mo ay bababa sa 4.6 kasi ang sinusunod natin class na ugnayan ng pressure at volume, yun dapat ang masusunod. Next naman natin class, let's say for example class, you were given your initial pressure is 115 PPA. And your final pressure naman class is equal to 625 torr, unit yan natin class, System International Unit, or SI unit na ginagamit natin class sa chemistry for pressure. And the initial volume class is equal to 3.5 liter. And the final volume now is missing. Yun ang nawawala. So therefore, class, first to analyze. The initial pressure class and final pressure class are not uniformly when it comes to their unit. Yung isa, kilopascal, yung isa, torr. So anong susundin mo? Ang sinusunod nating class na unit when you are about class to meet some disputes like this ay sa final pressure, yung torr. Lagi niyong pakakatandaan mga kapatid na ang sinusunod nating class na unit ay yung nasa final. Kasi pag sinabi natin final, yun talaga yung sinasabi natin class na original na unit na ginamit natin at hindi yung nasa initial. So therefore class, sabi natin dito, first thing to do is to convert PPA to torr. So, applicable din ba yan sa volume? Yes. Lagi tayo class kumbaga nagbabase sa final when it comes to unit disputes. Disputes, hindi pagkakaintindihan o hindi pagkakaunawaan. Kumbaga sa Tagalog. Okay? Sabi natin dito class for every 101.3 PPA is equivalent also class to 760 torr. So therefore class, 115 GPA, nagpapaksip pa. 115 GPA times 101.3 PPA is equivalent to 760 torr. Ayan. And then, makakancel class ang parehas na unit. Then you proceed class to multiplication and division. So, 115 times 760 divided by 101.3 Makakuha class ng value na alin? 862.84. So yun nga yung class ang ating magiging initial pressure at ang ating final pressure class ay 625 torr. So let us now try to analyze class the given. Ang ating initial pressure class ay 862.8 torr. And then yung ating final pressure class ay 625. What can you observe? No, ang ating initial is 862 and it went down. Bumaba siya. Bumaba class ang ating pressure. So therefore, class, when the pressure class decreases, what will happen now class to our volume? We can expect that the final volume class that we are trying to look for should also class in a higher value. Kailangan sabi natin dito, mas mataas class ang ating final volume sa kanyang initial volume. Okay? Kasi ang ating pressure class ay bumaba. So let us now class solve kung tama nga naman class yung relationship na na-conclude natin. Initial pressure, initial volume is equal to final pressure times final volume. Substitute tayo. Ng ating initial pressure ay 862.8 torr times ang ating initial volume 3.5 liter equal to, napapaksip pa, ang ating final pressure class ay ang 625 torr. Okay? And then the final volume ang nawawala. Right. And then divide both side class by 625 torr. This will become cancelled. Divide both side by 625 torr. Ayan. And then cancel with the same unit. Okay? And then sabi natin dito, ano? Ayan, nailagay natin yung mga dapat natin ilagay. So therefore, class, ang ating final volume ngayon is equal to, ayan. So 862.8 times 3.5 divided by 625. Ano ngayong class ang ating magiging sagot? Magiging 4.83. Ang ating final volume ngayong class ay 4.83 liter. Okay? Kanina, ang sabi natin, since ang ating pressure class ay nag-decrease, dapat ang ating volume ay mag-increase. So, ang ating initial volume class ay 3.5 liter. At saka ang ating final volume class ay 4.83 liter. So, we are correct, no? Our volume class increases. Tumaas class ang ating volume. From 3.5, it became 8.43. So, tama tayo. So, dito sa relationship class between pressure and volume, so you can somehow class have what we call guide on how you're going class to make your answer. Alright? So, that is class what we call Boyle's law. Next is the what we call Charles' law. In Charles' law class, it is the relationship between volume and temperature. And the relationship of it is directly proportional. Hindi katulad class kay Boyle's law that the relationship class between pressure and volume is inversely. So dito, ang pinag-uusapan natin dito ay volume and temperature and they are directly proportional for Boyle's law. So we have here now class a short video clip about what is Boyle's law all about. So let us watch this one.
Today on Sci Guys, Charles Law. Welcome to Sci Guys. I'm Ryan. And I'm Mark, and welcome to part 2 of our series on the laws of gases, Charles Law. Under temperature. Charles' law states that in a closed system, temperature and volume change proportionally to one another. That is, as temperature increases, so does volume, and vice versa. The equipment we need for this episode is heat-resistant beaker or glass, some balloons, some boiling water, and a fridge or freezer to cool our balloons in. In this experiment, we're going to be using boiling water, so for safety reasons, we highly recommend the use of goggles, temperature-resistant gloves, and an apron or lab coat to protect from spills and splashes. The first step in our experiment is going to be to blow up our balloon. Now, if you watched our previous episode, we're going to want to blow it up a little bit more this time. So try it off like so. There we go. The next step in our experiment is to pour boiling water into our glass beaker. Place your balloon into the beaker. In our first attempt at this experiment, we used a water balloon in boiling water. As the water balloon sits on top of the boiling water, it gradually increases in size. There's only one problem with a water balloon. They tend to pop because of their small size. In our second attempt, we used a full-size 12-inch party balloon and less water. We also placed a lid on the top to contain the hot air inside the beaker. In this version of our experiment, we see a more dramatic change in the balloon's size, as well as a much lower risk of the balloon popping. For the second portion of our experiment, we're going to place a balloon into the freezer. Leave your balloon in the freezer for a few hours. After a couple of hours, when we remove our balloon from the freezer, we'll notice it's smaller in size. As it warms up, it will gradually increase in size. Let's look at this experiment a little closer. Charles' gas law states that when a fixed amount or mass of an ideal gas is kept at a constant pressure and in a closed system, then its temperature and volume are directly proportional. What this means is when temperature increases, volume increases, or as temperature decreases, volume decreases. As we mentioned in our last episode, an ideal gas is a theoretical gas composed of a set of randomly moving, non-interacting particles. Under normal conditions, many gases such as oxygen, hydrogen, and some heavier gases like carbon dioxide will behave like an ideal gas. This means they follow the laws of gases such as Charles' law. In our experiment, our balloon is filled with gaseous air molecules. When the balloon is placed in the beaker with boiling water, the energy from the higher temperature water and steam molecules transfer to the lower temperature air molecules inside our balloon, exciting them. When the air molecules in our balloon are excited by raising their temperature, they spread further and further apart, increasing the volume of space they take up. The higher the temperature or the more energy the air molecules get, the larger our balloon will grow, or in other words, the greater the volume of space our gas will take up. If we remove our balloon from the hot water, the air molecules inside our balloon will gradually lose the energy they've been given, dropping back to room temperature, causing the balloon to shrink in volume back to its original size. In the second portion of our experiment, we place our balloon in a freezer, which causes a transfer of energy in the form of heat from the warmer air molecules inside our balloon into the cold freezer. As the energy is removed from our air molecules, they slow down, drop in temperature, and get closer and closer together, decreasing the volume of space they take up. The colder the air molecules get, the closer together they will be. If the temperature of a gas is lowered low enough, it will go through a change in state from a gas into a liquid. When we remove our balloon from the freezer, the air molecules inside will gradually gain extra energy from the air in the environment, raising its temperature, causing the balloon to increase in volume back to its original size. By changing the temperature of our balloon, we can clearly see the directly proportional relationship between the temperature and volume of an ideal gas. This relationship is known as Charles' law. Well, that's it for episode 2 of our series on the laws of gases. Thanks for watching.
If you enjoyed this episode, let us know in the comments below and subscribe to future episodes.
And don't forget to like us on Facebook and follow us on Twitter.
And if you have any questions related to this episode or about science in general, let us know in the comments below or message us on Facebook, and we'll try to help you as best possible. Thanks for watching. Bye. Under temperature.
All right. So that is the what we call class Charles law. So may himayin natin siya. So let us dissect each details that we have watched. Okay? So ayan. So dito muna tayo class by introducing class 2. It's Charles law. Who is Charles law tuloy? What is Charles law? I mean, And who is the person behind this law? Na tinatawag natin class na si Jacques Charles, no? He formulated this law in 1780s. Charles' law class is a gas law that states gases expand when heated. The law is also known as the law of volumes, no? Medyo kakalimutan na ang Charles law pala ay tinatawag din pala as law of volumes. Okay? And then, who is the father of modern chemistry? Robert Boyle. Huwag niyong kakalimutan, mga kapatid. Okay? Then, sabi natin dito, ano? The law takes its name from French scientist and inventor, yours truly, si Jacques Charles, who formulated it in 1780s. Ngayon, we mention class the relationship between volume class and temperature as they are directly proportional. Pag sinabi class natin na directly, sa Tagalog, direktang tumataas. Pag tumataas class daw ang ating volume, direktang tumataas din class ang temperature natin and vice versa. Kaya sabi natin dito, ano? When the volume class increases, the temperature also class increases simultaneously. And when the volume class decreases, the temperature class decreases. Sabi natin dito, ano? Why the volume class increases when we increase the amount of temperature? Simple lang, dahil may tinatawag tayo class na kinetic energy. Kinetic energy class is responsible for the movement of the particles. Movement of air particles. Sabi nila particles. Particles. Ayan, no? Sabi ng kaklase ko dati, particles daw. Yan, pag sinabi natin class na kinetic energy, it is a kind of energy responsible class for the movement or random movement class of the air particle inside of each container. Ngayon, sabi natin dito, as you increase the source of heat, habang tumataas class ang ating temperatura, lumataas class ang tinatawag natin na kinetic energy, and as the kinetic energy class increases, what will happen class to the motion of the particle? They also class about to bombard to each other, sabi natin dito harshly. Talagang nagbabanggaan niya sila, nagbabanggaan at nagbabibrate yan sila hanggang sa nagkakapag-create sila class ng pagtaas ng space or volume. Ngayon, sabi natin dito, pag halimbawa naman daw, sabi natin dito, bumababa ang ating tinatawag na temperatura, as the temperature class decreases, what will happen class to the kinetic energy? It decreases also. Kaya kung mapapansin nyo class, yung balloon kanina, nagre-reduce ang kanyang size. May kinalaman niya siya class sa tinatawag natin na third law of thermodynamics or 3. Ay, nawala. 3 laws of thermodynamics. First law of thermodynamics class is the law of conservation of energy. Okay? Law of conservation of energy. Ang second law naman natin class ay tinatawag nating class na law of entropy. Ang third law naman natin, ay malulubat na ako sa bitang. Ayan. Ang third law naman natin class sa thermodynamics ay tinatawag nating class na absolute zero or may ibang katawagan pa yan, crystalline solid. Ngayon, sabi natin dito, ano, applicable sa class sa pang third law ng thermodynamics that as we go, as the temperature class decreases, sabi natin dito, it reduces its size and eventually it becomes what? Solid. Kaya kung mapapansin nyo class, sabi natin dito, no, lahat ng bagay na sobrang lamig, ang titigas nila, nagiging solid sila. Ngayon, balik na rin naman natin. As the temperature class increases, what will happen class to the particle? It becomes ion. Yan. Ngayon, it becomes ion na ano kasi nagiging ionized yan. As the temperature class still continues to grow from ion, it become plasma. And one of the best example class plasma is the sun and lightning. Plasma class is considered as the first state of matter in the universe. It's not solid, it's not liquid, it's not gas, it's plasma. Ang pinakaunang state of matter daw class na nagawa right after Big Bang. Ganun. Okay? So ngayon, so let us now class try to apply the formula given by this particular law na tinatawag natin na Charles law or Boyle's law. Tama ba? Boyle's law. Yan. The law of volumes. Tama tayo. Ang formula natin dito, class, for Charles law ay initial volume over initial temperature is equal to final volume over final temperature. So this is class the formula for Charles law. So let us now proceed class to our example number 1. Remember class that all temperature class in gas law should be converted into Kelvin. Lord Kelvin believed that every gas in this planet has this particular temperature na tinatawag natin class na Kelvin, na mayroong corresponding value class na 273.15 kapag complete value. Yung iba namang class, nira-round off nila class into whole number na nagiging 73. Yan ang kadalasan ginagamit class ng mga teacher kasi yung iba kapag nakakita na sila ng decimal point, nararattle na sila, kinakabahan na. Kaya ginagawa nila, whole number na lang nila. Pero dito sa ating gagamitin natin class, ang standard value class ng Kelvin na 273.15. Okay? Ngayon, suppose you were given class, no, an initial volume of 2,800 cubic meter. Okay? And then the final volume class is the variable that is missing, nawawala. And ang ating initial temperature class ay 1 degree Celsius. And ang ating final temperature naman class ay 353.15 Kelvin. So anong susundin mo class na unit for temperature? Aside from the fact that we follow class the standard unit for temperature na Kelvin, you can easily also class distinguish which unit class are you going to use for temperature kasi ang ating final temperature class ay naka-Kelvin. Okay? So since 1 degree Celsius lang naman yan, sabi natin dito, mag-a-add ka lang ng 273.15. Walang mababago. Okay? And then we let us now class proceed to substitution. Ang ating initial volume class ay 2,000 cubic meter. Ang ating initial temperature class ay 273.15 Kelvin is equal to ang ating